Good morning, everyone.
Morning.
So let's number first for prayer. Almighty Father, thank you for today. We thank you for the breath of life you have given us. Let your Father and the and Father into your hands. We dedicate this lesson into your hands. We bring to you what we are going to learn today. Our teachers, our minds, our participation here. We pray that as we are going to start this lesson, may you come and intervene in our understanding, in our people's explanation towards our understanding the word. May this message show within us. May you be free to us today. We ask to us to know that we understand that the Lord is the King of because we just know this lesson. May you will be in Jesus' name we pray and believe. Amen.
Amen. Thank you so much, Deborah, for the word of prayer. I'm really very sorry. Uh, Something happened on my network, so I was struggling to get in. Yeah, but I was awake, but I don't know, something was happening. But thank you so much for being patient, and I'm sorry, but we are going to continue. We shall compensate for, I think there have been 10 minutes. Yes. Today, we are going to look at the intersection of two lines. That's where we are going to concentrate, intersection of two lines. Now, I know you have looked at intersection a intersection at O level, you looked at spontaneous equations. You looked at spontaneous equations, and that's why you looked at a bit of intersection. Now, when we look at the two-dimensional space, we have only two cases that in two dimension, either you can have your lines go like this, or your lines must meet. In two dimensions, like when I have 2x plus y is equal to maybe 5. This is a line in two dimension. So when it comes to two dimension in x and y, the only cases we can have is that your lines can either be parallel or your lines are meeting somewhere. So there are no any other case. So we are going to look at how do we determine that maybe lines are parallel or they're intersecting in two-dimensional space. So we shall look at a case when we are looking at two dimension. However, when it comes to a three-dimensional space whereby you have your X, you have your Y, and then you have your Z. What do we have to do? So either you may have a case whereby your lines are parallel, maybe you have lines like that are running like that, or you can have those lines when they are not parallel and intersect. So you can have a case whereby your lines are going like this and they are meeting somewhere. But also you may have a case where the lines are not parallel and they are not intersecting. And this is what we looked at briefly yesterday, what we called the skew lines. Now we are going to look at all the three cases. We are going to look at parallel. We are going to look at the cases at a case where lines are intersecting, and also we are going to look at a case where those lines are not intersecting. But one thing we need to take into consideration is that whenever we talk about parallel lines, then we do expect them that those lines are always in the same direction. And we say that if something is parallel, then the only thing we have to look out for is that in case I have a three-dimensional vector, let me say it is 1, 2, and 1, and I have another vector which is 2, 4, and 2. The only thing you have to look out for is that when you look at this vector and this vector, is there any digit which when you multiply by one of the vectors, you get exactly the other vector? If that happens, then it means that those two vectors are parallel. Sometimes even if you just check out for the ratio, like this is x, this is y, this is z, This is X, this is Y, and this is Z. So when something is parallel, you'll find that the ratios are the same throughout. In other words, when I get this as one vector and this, and I say 1 out of 2, is it equal to 2 out of 4? Is it equal to 1 out of 2? You'll find that the ratios are the same for all the vectors. Then that is an indicator that those vectors are parallel, given that you have read out the what? The directions for those vectors. So that's what we are going to briefly look at in today's session. So the first one we are going to look at non-parallel intersecting lines. And when it comes to a two-dimensional figure, whenever we have two lines that are not parallel, then one, you'll always just check out and then solve the simultaneous equation. So I'm going to first invite you. We look at that first case, and the first case we are looking at is non-parallel intersecting lines. Can you write this as your heading? Non-parallel intersecting lines, and then we are going to look at an example. We are going to look at an example. Okay, that is our first example. And I'm going to invite you now. Can we remind ourselves how to solve simultaneous equations in two dimensions? Feel free to use any approach of your choice, and let us first do it on our own. Mm. So I'm going to ask you, do it on your own. Don't use a calculator. Don't use a calculator. Just solve. You can use elimination. You can use substitution. Use any method of your choice. Mm. Someone may raise up the hand and briefly take us through quickly. Okay. Dr. Peace.
Good morning, teacher.
Yes, morning.
We solved the two equations simultaneously by elimination.
Okay.
So since we have a component, we have positive y minus y down. So we shall just add the two equations such that we eliminate y.
Okay.
So we shall have 3x, that is 2x plus x, we get 3x. Then y minus y, it's a 0. Then 11 plus 1, that's 12. So we shall have x equals 12 over 3. When we divide through by 3, so x is equal to 4. So we look now for the value of y from that equation. We shall have negative y is equal to 1 minus x, which is negative y is equal to 1 minus 4, which is a negative 3. So when we divide through by negative 1, we shall have y is equal to 3.
Okay.
Which means that the exact position is now 4, 3.
Okay, thank you. Thank you. So members, that's how I expect you to have that. Now you conclude that the exact position of the street light is 4 and 3. Now, what about when the lines are parallel? Now, in case the lines are parallel, the only thing you look out for, one, is that how is their gradient? That position for the gradient is the one that determines whether those lines are parallel. So I'm going to clean my screen. Now, in case the lines are parallel, the only thing you have to look out for that if this is our first line, let me say it is mx plus c1, and this is a second line, which is mx plus c2. The only thing you look out for, you check out this component here. As long as these two components are the same, take an example, y is equal to 2x plus 5, and the line y is equal to 2x minus 4. These two lines are parallel, as long as here and here, the things are the same. So that's the only thing you look out for, and then you conclude that those two lines are parallel, because the gradient is the same, and it is only the intercepts that do change. As long as the gradient is the same, then those lines are going to be parallel. Okay. Members, are we good to continue? Good to continue? Okay. Okay. Yeah, people are saying we can continue. Now, we go to the third case. The third case is for a three-dimensional figure. Now, for a three-dimensional figure, like I've said, that we have three situations that we are going to meet. Either they can intersect, either they can be parallel, or they can be skew lines. So how we solve them, the approach is the same, but the conclusion is what matters, whether they are parallel, whether it is skew, or whether they are intersecting. Now you are going to take note that if those lines are skew, you'll find out that you'll find out the solution is different for the different parameters you do obtain. Now, allow me that we start with an example. Take an example. We have, these are our vector lines. This is R and this is R. And they want us to find the point of intersection and the coordinates for that point of intersection. What is the first thing you have to do? The first thing you have to do is that, can you write them in a parametric format? So I'm going to first write R in that format. So I'm going to come and I say, I'm going to come here and I say, for my first R, I have my R equals to I minus 2j minus 4k plus lambda into negative I minus j plus k. So I'm going to write it in the form of x, y, z equaling to, in a column form, 1, negative 2, negative 4, plus my lambda into negative 1, negative 1, 1. From this step, I'm going to continue and I simplify and I write this as 1 minus lambda, negative 2 minus lambda, negative 4 plus lambda is equal to my x, y, and z. So the first step, we are going to write them in a parametric form. So what does it mean? It means that your x is 1 minus lambda, your y is negative 2 minus lambda, and your z is negative 4 plus lambda. Then the second bit, I'm going to write this second one in the same format. So I have my r, which is equal to 2i minus 2j plus k, then plus mu into I plus 2j minus 7k. So in that format, it means that we shall have our x, y, and z equaling to 2, negative 2, and 1, then plus our mu into 1, 2, and negative 7. What am I going to do? I'm going now to write it again. X, y, z is equal to 2 plus mu, negative 2 plus 2 mu, and then I'll have 1 minus 7 mu. Now, what does it mean? If these two lines are to intersect, it means that this R will equal to this R. That is the meaning. It means that these two are going to be equal to. Now, what we are obtaining here will equal to what we have here. Or someone can as well first equate X and the x component here. So you are going to allow me to equate the two. So I can just come and say that if those two lines that meet, this x and this x should equal y, and the y for this should equal z, and the z for this should equal. So that means that I will say 1 minus lambda should equal to 2 plus mu. Then that is for the x component, for x component. So I can first simplify it and I write it as negative lambda minus mu is equal to 1. So this is going to be my first equation. Then after, I'm going to say for the y component. For the y component, it means I'll have negative 2 minus lambda is equal to negative 2 plus the 2 mu. When I simplify, it can be negative lambda minus the 2 mu is equal to negative 2 plus the other 2. I'll end up with a 0. Then what about for the z component? For the z component, what am I going to have? I'll have negative 4 plus our lambda is equal to 1 minus the 7 mu. So when I simplify, I'll have lambda plus the 7 mu is equal to 5. So this is going to be my third equation, and this is going to be my second equation. Members, let me know whether we are okay up to that point. Are we okay up to that point? Are we on the same page? In case you feel we are not on the same page up to that point, kindly feel free to raise up the hand and then we support you from there. Now, in case you feel we are at the same page, I want you to solve the pair of simultaneous equations. You just combine any two of your choice and then you solve them simultaneously. So you can look at one and these two. Okay, peace. First right, no problem. So get this and this. Or you can get 1 and 3. Or you can get 2 and 3. So you just look out for any two pairs of your choice and then we work them out. You solve them simultaneously. Okay, so I'm going to use the first one and the second one. Or for me, I can use the first one, the second one, and the third one. Any choice of any that you feel you like. So maybe I can say now solving for lambda and mu simultaneously. So for you, look for any pair, you'll get the same answer. So I can say negative lambda minus 2 mu is equal to 0, and I can use the third one, which is lambda plus 7 mu is equal to 5. And for me, it is because I have seen a lambda here that I want to eliminate quickly. So when I add the two, I'll end up with something. But let us first work it out on our own. And we get the value of lambda and we get the value of mu. Okay. So I'm going to ask Chris. Chris, you may ask, where is the problem, Chris? Chris, if you could unmute. Because I was saying, yes, Chris. Which step?
The first step.
Wait, this step?
Mm.
No, this step is from the question here. I've just copied it from the question, where the equation was. Then if it is this step, remember, this is your x component, this is your y component, and this is your z component. X goes with the I, y goes with the j, and z goes with the k. Then the only thing you do, you extract the component, the coefficients. That here there is an hidden one, which is this. Here there is a negative 2, which is this. Here there is a negative 4, which is this. Then do the same here. This is negative 1, which is here, negative 1 here, and 1 here. I don't know if that is okay, Chris, or not.
It's okay now.
Okay. Okay. I've seen mu is 1, lambda is negative 2, mu is 1, lambda is negative 2, Martina. Okay. So I'm going to, where do we, no, it, like we are, John, this is we are solving simultaneous equations. You can add or subtract. You can use any method of your choice. But why am I adding? Here there is a coefficient of 1. Here there is a coefficient of 1. And you know that in simultaneous equation, when you are using the elimination and you check out that the coefficients are the same signs, you subtract. Different signs, you add. So here the signs, this is negative, this is positive. That's why I'm adding, such that I can eliminate them. So negative lambda plus lambda, I'll get a 0. Negative 2 plus 7, I'll end up with a 5 mu, which is equal to 0 plus 5, which is 5. So my mu is equal to 1. Then for my lambda, I still fill in. So this is why we add, because here again we have an addition. You are seeing this addition here. That's why we add. So I have 1 plus negative lambda. Here there is an addition. Then members are telling me that for the second one, for lambda, still I will say negative lambda minus 2 times the 1 is equal to 0. And members are saying negative lambda minus 2 is equal to 0, and then lambda is equal to negative 2. That's what members are getting. So that is very correct. Now, what do you do? After obtaining your constants, these parameters of yours, what do? You go back and you first fill in the components of x, y, and z. Now, if these two lines are going to be intersecting, what does it mean? It means that when you fill in the value of lambda here and the value of mu here, the components should be the same. In other words, the coordinate should be the same. So I'm going to go back and I can call it testing depending, or now checking. You can now check. So since I don't have space, I'm going to write here, I'm going to say checking. So you come here where there is lambda, you've put in the value you have got. Where there is mu, put in the value you have obtained. Such that you find out whether those values you have obtained are consistent. So allow me to remove this, and I want you now to check out for your lambda, check out for your mu in both. If you find out that in this case and this case, when you feed in the values, you get the same answer, then that is an indicator that those two lines are intersecting. So I'm going to come here and I say 1 minus my lambda, then negative 2 minus my lambda, and then negative 4 minus my lambda. And then when I check here, this is 3, this is 0, and this is negative 6. Do the same here. Check out, put in your mu. So here, when you put in, say, 2 plus 1, negative 2 plus 2, 1 minus 7 when you put in. So you notice here that I'm also going to get 3, 0, and negative 6. Now, the moment you find that for this line and this for this line, the value you are getting are the same, then it means that those lines do intersect. So here, they have told you to find the coordinates of intersection. Remember, when you are writing a coordinate, we write them in horizontal format. So I'll come here and I say that the coordinate for the point of intersection is 3, 0, and negative 6. And therefore, you conclude from there. So if for intersection, it means that the two values you get for the first line and the second line, they must be consistent the moment you fill in their parameters. Members, are we on the same page? Okay. Hope we are not leaving anyone behind, and we can now, okay, people saying yes. Okay, good. Okay, yes, okay. I'm going to remove this screen and we have another number. I have another number here. That is our second one. That is our second. Now, what am I going to ask you? I want us to first, when you look at this line, the first thing you have to do is that, can you first write it in a way that you understand best in the vector equation line format? That is the first step you do. Transfer it from the Cartesian plane, from the Cartesian format, take it to the other. We said, do not forget that this is going to be R is equal to, allow me to just summarize here. Can we have someone to read for us what is going to be our vector equation for that line? Someone to read for us how that vector equation is going to look like. Yes, Linda?
Our R1
Mm-hmm.
will be negative, it's 0,
0,
negative 2,
negative 2,
5,
5, good, plus
plus lambda
lambda
1,
1,
2,
2.
negative 1.
Okay, thank you. Baswali, read for us for the second line.
Good morning, teacher.
Morning.
We have negative 1.
For the second line? For this one?
Yeah. Yes, teacher.
It's going to be okay.
Negative 1. We have
I'll
1.
note it. 1,
Negative 3.
Negative 3.
Negative 3. 4.
4. Good.
Plus
Mm.
mu into negative 1. Negative 3. 1.
1. Thank you. Thank you, Baswali. Can I have another one as well? So members, the moment you extract them very well, feel free now to continue. Can I have another person to simplify it for us further? I wanted someone. Okay. Okay, Shadia and Melissa. Shadia, you're going to do for us one part and Melissa the other side. Shadia, do for us. Oh, Shadia, you are muted. Melissa, stay. Morning. Oh, I don't know why Shadia mutes. Melissa, can you first take us through?
XYZ
XYZ.
is equal to lambda
Lambda.
negative 2 plus 2 lambda
Negative 2 plus 2 lambda.
5 minus lambda.
5 minus lambda. Okay. Thank you, Melissa. Shadia, are you back?
Yes, sir.
What shall we have this side?
We shall have 1 minus mu,
1 minus mu.
negative 3 minus 3 mu,
Okay.
and 4 plus mu.
Okay. Thank you. Thank you. That is okay. Linda, can you equate for us?
For x
For the
component,
x component.
we shall have lambda equals to 1 minus mu,
Okay.
which will be lambda plus mu equals to 1.
Equals to 1. Good.
For the y component,
Okay.
negative 2 plus 2 lambda equals to negative 3 minus 3 mu,
Okay.
which will be 2 lambda plus 3 mu equals to negative 1. For the Z component,
Okay.
5 minus lambda
Mhm.
equals to 4 plus mu.
Okay.
Negative lambda minus mu
Mhm.
equals to negative 1.
Okay. Thank you. This is our second, and this is our third. Okay, thank you. John, I saw your hand up. Okay. So can we solve now? Sort of, feel free always to choose any pair of simultaneous equation. However, sometimes you may find out that when you choose the same pair, they are the same. So that one, you need to think about it. Sometimes they are the same, so make sure you don't choose the same equations. Yes, Antonia?
I wanted to solve.
Antonia, we go.
So I'm going to solve equation 1 with
Equation
equation
1.
3.
Equation,
So I'm solving 1 and 3.
like this?
Yes.
Antonia, can we look at this one critically and this one critically? What are you observing?
The signs are different.
Okay, so what are we going to do?
We're going to add.
Add and we see.
So when we add, we're going to eliminate, let me see. They're literally giving us 0, like both of them.
So now that's what I was saying, because when you look here, Antonia, when we divide
Yes.
through by -1, are you noticing that this equation is going to be the same like the first one?
Yeah.
So that means that now you need to make another choice.
Yeah.
So make another one.
Let us use the first and the second.
Okay.
So we are going to eliminate lambda.
Lambda.
So that will be 2.
2.
Then the down of, I don't know how to say it, but I know how to write it.
Okay, tell me what to write.
Then the bar.
The bar like this?
Yes.
Uh-huh.
So lambda plus mu equals 1.
Okay.
Then the other part, we are going to have 1, 2 lambda plus 3 mu.
Okay.
So we are going to multiply throughout. Therefore, we shall get 2 lambda. Then 2 mu equals 2.
Okay.
Then the law will remain the same. That will be 2 lambda plus 3 mu equals -1. So here the signs are the same. We are going to subtract.
Okay.
So that will give us negative mu.
Negative mu.
Minus to give us 3.
Okay.
Therefore, mu will be equal -3. Then we are going to substitute in the first equation.
Okay.
Mu plus mu, that will be lambda minus 3 equals 1. And that will be lambda equals 4.
Okay, thank you. Can you first check now for us? We'll continue, Anthony, and you check.
Now we're going to go to the first one. That will be 4. Then negative plus 2 into 4, that will give us 6.
Okay. This is 4. This is 6.
Then 1, 5 minus 4.
Okay, good.
And the second one is
Mhm.
1 minus 3, negative 3 minus 3 times negative 3, then 4 minus 3. First one will give us 4. Second one will give us 6. And the last one will give us 1.
Good. Go on and complete the question.
So yes, the lines intersect, and the point of intersection will be 4, 6, and 1.
Okay, thank you so much, Antonia. Yes, so members, that's what you had to do. Yes, John, is it a question?
Yes.
Yes.
Morning, sir.
Morning.
I missed a lesson, but want to help me in the first step to form the way you.
Now, John, one, like when you look at these equations, these ones here, we just read
R
up
is
the
equal to
component.
0, negative.
Hey, you read up the component here. You read up the
Yeah?
component here. Those are the components. And that's the known point. What you have down is the direction. So here there is a 0. So that's why we carried a 0. Then here there is a positive 2. But if it is a positive 2, then you take it as a negative 2. Because for it to become positive, it means it crossed. Because that was y plus 2 out of 2 is equal to a parameter. So this means it was y plus 2 equals to 2 lambda, which was y equals to negative 2 plus 2 lambda. So that value was negative 2. So that's why here we carry a negative 2. If you want still also for you, it says z minus 5 out of negative 1 is equal to a parameter. So that means that this is z minus 5 is equal to negative lambda. So z was equal to 5 minus lambda. So this was a positive 5, so you carry that positive 5. Then what accompanies the lambda is the direction. So this was negative 1. That's why we have a negative 1.
Thank you, sir.
Okay. Members, are we on the same page? Can we now continue? Are we good to continue? Okay. Okay. We are good to continue. Okay. I think now we can look at a scenario. Okay. Can you read through that scenario of ours? So go through the scenario. Mhm. Okay. Yeah. Now, they have told us that we have this engineering team that is constructing some tunnels. They have given us where the team is beginning from and the direction. The other team from where it is digging, and the first part, they are asking us that use vector methods, show that the two paths will eventually meet at a point, hence determine the coordinates of the point P. Members, should we first try it on our own? Shouldn't we first try it on our own? Can I first invite everyone to first try it? Let me first put space. I think we can first try it on our own, right? Good. Let's try it. Okay. Yeah. Let's first try. So try on your own. So I expect you to, one, to be able to first find out the vector equation before you proceed. That is the first step. So let me first give you some 3-4 minutes for everyone to first try. The moment you get your mu and lambda, put them in the chat, and then we can now start from there. But let's first try it on our own. Okay. Okay. Let me put it in that format. Shiba, Shiba.
Yes.
Yes, can you give us a jump start for your just for the first equation, what you have, because we need to know whether people are on track. The first one, just. Mm-hmm. Yes, Shiba. Okay, Martina has already finished. Okay, Martina, give us a jump start.
Morning, teacher.
Morning.
So I started with point A. So I said R1 is equal to, then the columns, -3, -3, 9, plus lambda 2, 2, -1.
Okay.
Then that's our point A. Then for point B, that's R2, I said -19, -7, -3, plus mu 6, 3, 2.
Okay. Okay.
Then I went back to R1 and got R1 is equal to -3 plus 2 lambda
Okay.
minus, -3 plus 2 lambda again, then 9 minus lambda. Then when I go back to point B, it was -19 plus 6 mu, -7 plus 3 mu, and then -3 plus 2 mu.
Okay.
So I equated both the things. So I now began looking for the x component. Then I said -3 plus 2 lambda is equal to -19 plus 6 mu. So yeah, I brought the -19 to this side to make it a positive, and then I took the 2 lambda the other side. So it becomes -3 plus 19 is equal to 6 mu minus 2 lambda. And then I got 6 mu minus 2 lambda is equal to 16. That's our, okay, I call it equation A for me.
A, okay.
Yeah. Then for our y component, I got -3 plus 2 lambda is equal to -7 plus 3 mu. I took the 7 on the side of 3 and I took negative to this side. So it became -3 plus 7 is equal to -3 plus 7 is equal to 3 mu minus 2 lambda. Then I got 3 mu minus 2 lambda is equal to 4. Then for component Z, I got so I got 9 minus lambda is equal to -3 plus 2 mu. I took 3 on the side of 9 and negative lambda on the side of 2 mu. So it became 9 plus 3 is equal to 2 mu plus lambda. Then I got 2 mu plus lambda is equal to 12. Then I used equation A and equation B to find my mu and lambda as 4. Both of them are 4.
Okay. Okay, good for, okay. Have you been able to get the point? Okay. Members, I don't know whether you agree. Kindly check out whether we are getting the, okay. Mu's 4 lambda is 4, Dr. Peace. Hans, Mu's 4 lambda is 4. Oh, Linda, can you check out? Linda, something is not adding up. Eh, Linda, check out something is not, At Atalantis, yes, you're on track. I don't know this one. Is it Zion? Yeah, that is okay. Toshiba, that's okay. Thank you, Martina. Moses, which signs are you talking about? Moses, I'm not getting you what you are saying by signs. You can unmute. Gilbert, that's okay. Wafla, that's okay. Chiza, that's very fine. Elio, that's okay. Toshiba, that's okay. Hans, that's okay. Bettina, okay. In
Hello,
case
teacher.
we... Hmm?
Teacher, I was meaning these signs. We had -3, -3, and 9.
Like, I
So
see the coordinate here. The point here.
yes.
Hmm.
So I mean, why are those signs not changing? Like in the previous example we had, signs
Okay.
were changing, and this time round nothing is changing.
Okay, now there are two things now you need to understand. The first
Yes.
examples we did, an
Mm.
equation a vector equation.
Yes.
Bettina, I saw Bettina's hand up. Bettina, unmute. Did you want to respond to support?
No, I
Okay.
just had also a question.
Okay, keep your mic open. Now, Moses,
Yes,
the vector
teacher.
equation can be written in
Mm.
three formats. It
Yes,
can be
teacher.
written in this format, which is the vector equation. It can be written in a parametric format, and it can be written in a Cartesian format. Now, the cases
Mm.
we are looking out for, the equation had already been transformed into a Cartesian plane.
Okay.
Now, this format here is they have given
Mm.
you the point and the direction. So they want you to write it in a vector format. So
Okay.
whenever they give you a point, you just read it the way it is. You don't change it. But
Okay,
this same
teacher.
equation, if at all it had been written in the Cartesian format, it would have been
Mm.
written like x plus 3 out of 2 equals to y plus
Okay.
3 out of 2 equals to z minus 9 out of -1. Now, if it
Yes,
was written in this format, then that
and
would be
that's when the signs would change. Okay.
uh-huh. That here in case it is positive, it becomes negative. Positive, negative, negative, it becomes
Mm.
positive.
Thank you so much, sir. I got it now.
Okay. Yes, Bettina. Bettina, you may ask as well. Members, I expect you now to continue. Oh, I think Bettina has dropped off. Okay. Yeah. So from the chat, members are agreeing that they're getting 5, 5, 5, 5. Very good. So the point, determine the coordinates of point P. Remember, whenever they ask you for the coordinates, you first check out when you substitute for your 4 and 4. You have to check whether here the coordinate is the same with the equation here. Because if you do not check, chances can also happen that the coordinates are different. It can also happen that the coordinates are different. Then also you can check out whether they are parallel by looking at the direction what? The direction vector. So Matia Mlomba is also getting 5, 5. Very good. So here I expect that we shall write our coordinates as 5, 5, and 5. But do not forget to come and show that surely that you are getting the same points. So you just come here and say, now I'm going to substitute 3 plus 2 times 5. Then -3 plus 2 times 5, 9 minus 5, and then you end up with your 5, 5, 5. But in coordinate form, we write it horizontally. And then you make a good conclusion that the coordinates or the point, the meeting point for the two tunnels is 5, 5, 5. Members, are we on the same page? Are we good to continue for part B? Are we good to continue for part B? Hmm. Okay, same page. Okay, yeah. So I'm going to clean my board. I'm going to clean my board and now look at part B. Though I know you are trying out part B. Now part B, I'm going to just first put it in the visual format such that you can get a bit of starting. Like these people are constructing a tunnel, and I know you people, you know a tunnel through a mountain to link two cities. The tunnel is being dug from both sides simultaneously, and engineering must ensure that the two digging paths meet accurately inside the mountain. Like your mountain, like this is your mountain, So you have a team that is okay. Yes, Dr. Peace.
Teacher, I just wanted to bring an idea. I don't know whether it's correct or wrong.
Uh-huh. Okay.
Okay, according to me, the way I've seen the question, it's like they are digging from both sides and they want those two lines to meet, and that's where they will stop. So, according to me, I think that we shall get the magnitudes of the two vectors. Then after we change we can add the two magnitudes because they want the total length.
Okay.
Then we change to meters according to the scale given in the scenario. I don't know whether it's
Perfect.
correct.
Yes, Dr. Peace, you're on track. On track.
Oh, thank you.
That is okay. That's okay. So members, I'm going to assume that for this is our mountain, this is the starting point for A, and this is the second point for B. Now, when people are digging, let me say this team will come here, and another team will come here, like that is how they are digging. Now, this point here is the meeting point P, which you have obtained as 5, 5, and 5. You remember? Then your point B here was -19, -7, -3. Then your point A here was -3, -3, and 9. Now, what is the most important thing? The most important thing is for you to know. Now, since they are interested in the length, to first know what is the length from A to P. What's the length from P to B? So I expect you to first find out what is A to P. So you're going to first find out vector A to P. After finding out vector AP, go on and find its length. Find vector. Here it is okay. You can say PB or BP. It is also, but in fact, even the best is, let me use PB. Why? Because you are starting from B and you are moving towards B. So also find out BP. Then we start from there. So hope members, you have understood what to do, like how even Dr. Peace has told us. So find out those two vectors. Alice, are we on the same page?
Yes, we are on the same page.
Okay, can you first give us just a start and people get a picture for AP?
Okay. To get AP, definition is going to be OP minus OA. And in this case, OP is 555.
Okay.
And OA is -3, -3, 9. So when you subtract, you're going to get 8, 8, -4.
Okay.
That is my AP. Then to get my BP, it's going to be OP minus OB. And my OP in this case is 555. And my BP is -19, -7, and -3. So I have 24, 12, and 8. Yeah, that's my AP and my BP.
Okay. How do we obtain the length for AP?
Magnitude of AP. Magnitude of AP will be root of 8 squared plus 8 squared plus -4 squared, which is 64 plus 16. Let me just okay, my calculator is giving me errors. Let me try to recalculate that. Yeah, it's 12. Okay, it's root of 144, which is 12.
Okay. Thank you. Okay. Okay.
Then for
Thank
my
you.
right.
For?
The magnitude of BP is the same thing, root of 24 squared 12 squared plus 8 squared. Yep, that's root of 784. Let me see. Yeah, right. No, something's wrong with makeup. But yeah, when you compute that, you get the final answer.
Okay, so calc has failed to give you the root of 784.
Okay, yeah, it's, I don't know. I think I threw it down. It's now frozen.
Oh, okay. Sorry about that.
It's alright.
Baswali, thank you. Alice?
Teacher,
Yes,
that root is 28.
28. Okay, 28. So from here up to here, members, I'm saying that it is 12. Then from here up to here is equal to 28. Remember, first complete it and you tell us what is going to be. Okay, I'm seeing some answers already in the chat. Martina is getting 2000 meters. 2000. Okay, very good. Baswali, you wanted to complete?
I wanted to complete, sir.
Okay, complete.
So these are like the meters we are having. They are 40 if we total up the 12 plus the 28.
Okay.
But they told us in the scenario that 1 unit represents 50 meters.
Mm.
But so far we are having 40 units. So we shall multiply the 40 with the 50 to get the 500 meters.
Multiply well.
We have okay, let me see. It is 2000 meters, sir.
2000 meters. Okay, thank you. How would you conclude?
I will conclude that therefore, the total length of the tunnel is 200 meters.
Okay, 2000 meters.
Yeah.
Okay, thank you. Anyone with finding a challenge such that we can support you, members, Bettina, that's okay, Toshiba, Santos, Tracy, Dr. Peace, Shadia, Martina, Olive, Esther, Vincent, Bettina, yeah, Gilbert, Shiba, yes, Samuel, yeah, Dr. Olive, yeah, those answers are correct. Those answers were okay. Okay, yeah. I think members, are we good to continue? Linda, yes. Okay, James says yes. Samuel says yes. Gilbert says yes. Okay, so now this is how you can find search in a scenario format, and that's how you can. Okay, Melissa, Shadia. Okay, same page, Tekino. Okay. Now why don't I give you some exercise? Some exercise. Yeah, you can just take a screenshot as I respond to Esther. Yes, Esther.
Okay, teacher, from on our previous number, I understood how we got everything, and even how we got, I think it was SP and BP, but then I just thought about it. Why is it wrong for us to add the vectors AP and BP, and then we find the magnitude at once? Because it gives
Why don't
gives a
we?
different answer if you do that.
If you do what? The magnitude of
But
AP
why can't we just add
like this?
no, if you get the vector AP, no, the vector
AP,
that we got the vector plus the vector BP, and then we get the magnitude at once. Why is it true?
And then you get the magnitude at So which answer did you get when you tried it out?
I got 37 point something.
Do you know why it is wrong?
No.
Okay, this is A to P, and this is, you got B to P, like this. B to P.
Yes. Yes. No, I got BP.
B, P, eh?
Yes.
So when you add A to P and then B to P, what? Because now this one cannot give you the right answer. But if you wanted to do it in that format, what you would have done, since we are looking out for A to B, that tunnel, you would have said A to P, P to B.
So that would have given me the right answer.
Yes, there you get the same answer.
Oh, okay.
Yeah, because vector addition is very important because you are interested in the tunnel from A to B. So that means in addition, you would have said A to P
And
plus
B.
P to B. Then you can get the same answer.
Okay, thank you, teacher.
All right. Okay, hope members have taken a screenshot. So you check out whether they are parallel, intersecting, or skew lines. For parallel, we say that the only thing you look out for is that check out whether, I think we did not do parallel. Let me see whether there is any parallel line here. Okay, let me use B. What you do, you extract out the direction first. You say my direction is 3. I'm just extracting the direction, -4 and 9. Then my direction for this one is -6, 8, and -18. Now, members, if I may ask in the chat, when you look at these two directions for this part B, is there any scalar which when you multiply you get exactly the other? Just look them using your eyes now. When you look at them, is there any scalar which when you multiply you get exactly the other? Members are saying 2, 2, 2. Yes, it exists. Then now this one means that there is that one of them is a scalar multiple of the other. Another person could even get the ratio. Let me say I get the ratio of 3 out of -6. Is it equal to -4 out of 8? Is it the same as 9 out of -18? So you see 3 out of -6 is -1 out of 2 is equal to -1 out of 2 is equal to -1 out of 2. Or another person who used -6 out of 3, that one is also okay. So you'll find out that the ratio is the same whenever it is parallel. In other words, that means that there is a scalar multiple, which when you multiply, you get exactly the other vector. So the moment you identify that, then that one you just conclude that this one is a parallel vector, or that pair is parallel vector. Yes. Then it is for intersecting and skew that you go on and check. But that one we are still continuing. Okay. Allow me to move on to the next screen. Can you take also a screenshot of this? Now here, I've asked you also to get the angle between L1 and L2. If I may ask, members, how do we get the angle? What do we use to get the angle for this part C? Because I know we may not look at angle, but someone to tell us how do we get the angles in case we have two vectors. How do we get the angle between the two? Or what do we use to get the angle? Okay, just looking through the chart to see whether someone. Perfect. Very good. Very good. Yes, yes. We get the dot product. Perfect. 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 Now those ones, don't forget. That one I've removed the members. Now we are going to look at specifically skew lines. Now yesterday we started on skew lines, and we said that the beauty with skew lines that they do not have a point of intersection, and when two lines are skew, they are not parallel and they do not intersect. That's what we looked at yesterday. But in case you want to write something in, you can just put something down. You can just put something down and then we start. So let me wait for you. In case you want to put something down, you do so, and then we start. Okay. You will let me know whether we can now continue. Okay. People are saying we are done. We can continue. Okay. We look at the first example. Now, this is our first example. Show that the lines with vector equations do not intersect. Now, how are we going to show? We are going to follow the same procedures the way we are doing for the other one. The first thing is we write it in the parametric format. That's the first thing. So in parametric format, when you look at our first line, someone to take us through the first one, the parametric format for the first line, how shall we write it? Okay, Melissa.
So this one will be x, y, z.
Okay.
Is equal to 4 minus 2 lambda.
Oh my God. Okay.
7 plus lambda. 5 plus 3 lambda.
Okay. Then the second one, let me write the second one as well.
X, Y, Z. Minus 6 mu. 1 minus mu. Sorry, 1 plus mu. Then 10 plus 4 mu.
Okay, good, good. Members, hope that step is okay. Melissa jumped a step there. But let me hope it is okay. Yes. Okay. Linda, take us to the equating bit of it. Thank you, Melissa.
For x component, we shall have 4 minus 2 lambda equals to 1 minus 6 lambda. So it will be negative 2 lambda plus 6 mu is equal to negative 3. That is our equation 1. For y component, 7 plus lambda equals to 1 plus mu. So it will be lambda minus mu equals to negative 6. This is equation 2. For z component, 5 plus 3 lambda equals to 10 plus 4 mu. 3 lambda minus 4 mu equals to 5. That is equation 3.
Okay, thank you, thank you. So now can everyone continue? And we first get what is our lambda and what is our mu. So solve. Okay, I'm looking through the charts. Okay, from the chart, members, from what I'm seeing, mu is negative 23. Lambda is negative 29. That's what I'm seeing from the chart. Negative 23. Eric, Dr. Peace. Okay. Members, do we agree with that? Do we agree? Hope members will agree with those two. Okay, Robert agrees. Hope the rest also you are agreeing that those two are okay. Okay, can we now substitute in? Can we now check out? Can we check out? Can we check out? Can we check out? Check out. From Tracy, she's saying when we feed in lambda here, 4 minus 2 times negative 29, 7 plus negative 29, and 5 plus 3 times negative 29. She's telling us that when you feed in the lambda, you get 62. You end up with negative 22 and negative 82. That is from Tracy. Martina is saying not equal. Okay, when we feed in here, 1 minus 6 times negative 29, 1 minus 29, and 10 plus 4 times negative 29. So from still Tracy, I'm saying she's saying 139. I'm saying she's telling us negative 22 and then negative 82. So I'll take Tracy's answer as the gospel truth that also everyone that those are the things you are getting. Very good. Yes. Now it is from that point, members, when you substitute, Tracy, those are the answers she has got, and I think I also agree with her that these answers are okay. Now, the moment you check out that the coordinate you have here, and the coordinate you have here, like these are vectors, but in coordinates, you check out that this one is 62, negative 22, this is negative 82. Here you have 139, you have negative 22 and negative 82. Now that is the indicator that those two lines do not intersect and not, yes, they do not intersect. So that means that how are you going to state your conclusion? You are going to say that the values of lambda and mu don't give a consistent point. So there is no point of intersection and the lines are skew. I don't know whether you have got it. I repeat, I've said that since the value, you are going to say that since the values of lambda and mu don't give a consistent point, so there is no point of intersection and the lines are skew. Or you can frame it the way you want, but the key things is that when you substitute in the values of lambda and mu, for point R for the two vectors, the point you are getting is different. They are not equal points, and therefore there is no point of intersection. So now the lines there you conclude that are skew lines. Any question? Yes, Esther.
Okay, teacher, I don't know if I'm the only one, but as I was solving simultaneously for the x and for the equation of the x and also the equation of the y, I was getting a different answer from y and z and maybe even x and z.
Where? Like when you substituted here?
No, on the solving simultaneously part.
Which equations did you use? Which equations did you use?
Okay, when I used the first one and the second one.
Okay, wait. You used the first one?
And okay, the first one and the second one I was just checking out, so I used the calculator.
Okay, which ones did you use?
I used the second and the third. And I got the answer. And I got the answer that everyone has been getting.
You got the answer everyone has been getting?
Yes. But when I tried out with the first one and the third one, I was getting a different answer.
The first one?
And the third one, I was getting a different answer.
Okay, take us through how you have used this one here. And we see how the answer is. What did you do?
Okay, I used the elimination part and I first eliminated lambda.
So you multiplied here by?
By 3 and down by -2.
So you ended up with?
-6 lambda plus 18 mu minus 9. Then -6 lambda plus 8 mu equal to -10.
Okay.
Then I got, that was...
What did you do? Subtract, add?
I subtracted. And I got 10 lambda, 10 mu is equal to equal to 19.
19, right? Sure?
Yes.
Is it 19?
Oh, then it was 1.
It was 1. So your mu is equal to?
1 out of 10.
1 out of 10. Then what is your lambda?
My lambda is
I'm waiting for your lambda. Hope she's
so
still
my
on.
lambda is 9 out of 5.
-9 out of 5.
So I was
Okay.
confused when I got two different answers for two different equations.
It is really very fine. It's really very fine. What matters now, we feed them here and see whether you get an answer that is different, because that is the proving part. That when I
Oh,
have this plus 1 out of 10 and 10 plus your mu, which is this. So you punch in and you tell us what you get here.
let me see. 1 minus. That's 2 out of 5.
Mhm.
Then 1 plus 1 out of 10. That's 11 out of 10.
Mhm.
Then 10 plus uh, that's 14 out of 5. Yes.
Yes. So the most important thing is for you, for whatever values you get, you may not get the same values, because being that it does not it's skew, don't expect to get. So when you solve the first and the second, what matters is look out for these points here you get at the end. As long as they are not the same, then you conclude from there.
Teacher, thank you.
Okay. Doctor, please.
Teacher, I just wanted to ask whether if I phrase my conclusion in this way, is it okay?
Okay,
Like,
phrase.
since when we substitute in the values of lambda and mu, R1 is not equal to R2, so the lines don't intersect. Since when we substitute in the values of lambda and mu, R1 is not equal to R2, so the lines don't intersect.
Okay, okay. It is well. It is well.
Okay, sir. Thank you,
Mm.
teacher.
Okay. Okay. So there is no point of intersection. So, okay. So I think we are good to continue. Yes. Mm. Okay. I have another one here. I have another one here. Mm. And let me hope now members are noticing one thing is that with vectors, we build up from one knowledge to the other. You're going to find some situations whereby they have given you a line. You're going to find a situation whereby you need to first get the vector equation. Now, like the situation we're dealing with, you have to know the direction and you have to get the point. So now you need to know how to deal with all those things, how you can form a vector equation when you have one point and you have the direction, how to form the vector equation when you have 2 points along the line. Yes. So I think we are trying it first, right? We agree that we first try it. Eh, eh, okay, let's try it first. Okay. So first try it out. Mm. Okay. Okay. Yes, Dr. Peace?
Teacher, I just need some hope because I'm really stuck. Like
Oh.
according to the scenario, they are showing that route A underground fiber optic cable passing through the points A and B. So I'm saying they are not clearly showing us the direction of vectors. So I've even failed to compile the vector equations, in fact.
Okay. Now, Dr. Peace,
Yes.
at one time, we looked at, we said that when we have 2 points along the line and you want to get the vector equation, there is something we said. In case this is O and this is R. We said that our R is given by OA plus, this is T, plus, for that one, you have to create the direction yourself, that I can create the direction going this side. So it is OA plus lambda A to B.
Oh, okay. Thank you, sir.
Okay.
Thank you, sir.
Okay. Yes, Linda and then Martina.
No, I just wanted to answer Dr. Peace, but you have answered her.
Oh, okay. Sorry. But can you give us for the part B, for root M?
For root M, we are going to investigate CB.
So it will be
CD
OC.
plus mu CD.
CD. Okay. Thank you. Yes, Martina.
Yeah, just like Linda, I wanted to help, but you
Okay.
helped out.
Okay. Help us from here now.
To get CD,
To get for one line, such that people can check whether they're on track.
okay, after getting the direction, for AB, I got direction of 10. Okay, AB is the direction. So I got 10, -4, -6.
How did you get there?
I said AB is equal to OB minus OA.
Okay.
And they're given us OB as 11, -2, -7. And then they gave us OA as 1, 2, and -1. So when I subtracted, I got 10, -4, and -6. Then I wrote down the formula of the vector equation of a line, which is R is equal to OA plus lambda AB, which is what we consider our direction.
Okay.
So I got our OA was 1, 2, -1 plus lambda 10 minus 4 minus 6. Then for CD, I did the same thing, OD minus OC. Then I got the final answer of CD was 7, -9, and then 6. So I still
What?
again wrote
7.
7, -9, and 6.
Okay.
So I wrote the vector equation of a line again, and then I said OC plus mu CD. So I got 2, -1, -3 plus mu 7, -9, -6. So the first
Hey,
thing,
this was -6, not 6.
sorry, 6, 6.
Okay.
So the first thing I did to check whether the what? I had first check whether the lines are parallel. Because you know that skew lines are not parallel and they also don't meet. So I used the directions, which are AB and CD. So I first put them together. So I said 10, -4, -6. Then 7, -9, 6. Then I looked at them and I was trying to see if there's any scalar, but there is no scalar.
Okay.
So then I realized that they are not parallel. Yeah, so that's where I am right now in the thinking.
Okay, continue. Okay. Shiba, your hand was up. Where is Shiba? Shiba, unmute. As also Shalom, you unmute.
Good morning, teacher.
Morning, Shiba.
I had a question. Since someone asked that there was no direction in the question, so is it possible if I could have done instead of AB, you do BA? Is it also correct?
Okay. If you do now BA, then that means that the best would have been, yes, BA is okay. That means that your starting point here is B and you're heading towards A. It is very correct. Is that fine? But now here, better, since you have started from B to A, then here better use OB.
Oh, okay.
Okay. Yes, Sharon.
Good morning, teacher.
Morning.
This is my first lesson here, and I'm confused why we are adding OA to lambda AB, and why we are adding OC to new CD.
Now, okay. Sharon, this one is what we call the general equation of a vector. Now, this general equation of a vector, how do we obtain it? You know how we obtain vectors. Let me say, I'm going to just give you a hint, but you'll get time. This is A, and this is point B, and this is R. R means any point along the line. Now, if I want to get O to R, it means that O to R, I can start from O towards A, plus from A towards R. Do you agree with that?
Yes, teacher.
That is fine, right? Now, from
Yes.
there, okay, just a minute. Martina?
Teacher, I can finish answering her. I was going to continue with the question.
Okay. Now, you remember, Sharon, that if I have this as my point A, this as my point B, and this as my point R, do you remember how we prove collinearity?
No, teacher.
Now there is a concept of collinearity, and collinearity means that for any points along a line to be collinear, one must be a scalar multiple of the other. Now for collinearity, it means that A to B is equal to a scalar, which now for this case we are calling lambda of AR. That there must be a common point, which is A, and then there must be a scalar, which when you multiply, you get exactly the other vector. Is that okay?
Yes, teacher.
If you
Yes,
don't
teacher.
write it like that, you can as well say, I can still write this that AR is equal to a scalar of A, B, like that. Now here where we have AR is where we substitute this. So this becomes O to A plus lambda A to B is equal to OR. So that's how we get this formula here we have.
Oh, okay, teacher. Thank you, teacher.
Okay. Now, but Sharon, now what you are going to do? You are going to go back. Yes?
Yes, teacher.
And you watch from the first video up to lesson now 12 where we are.
Okay, teacher.
You will try but I know in the next, if you understand this concept, I know the next parts we shall look at maybe tomorrow and the days that will follow, you'll be able to pick up slowly.
Teacher, can I ask? This is in coordinate geometry.
This is in vectors.
Oh, okay.
Coordinate geometry, coordinate geometry is a third term topic, and that's where you look at those things of ellipse, hyperbolas, and the rest of that.
Okay, thank you, teacher.
Okay. Okay. Yes, Martina?
Teacher, after identifying, I said using the second property of skew lines, they don't meet and they are not parallel. So I said to look for like whether these lines intersect. Yeah. So I said 1, 2, -1 plus lambda 10, -4, -6 is equal to 2 minus 1, -3 plus mu 7 minus 9, 6.
Okay. I wanted to look through the chat and check out whether members are getting the same things. Yeah. Members, are you getting the same things with Martina, or it is something different? Okay. Okay, Martina, we continue.
Then when I added them, it was 1 plus 10 lambda, 2 minus 4 lambda, and then -1 minus 6 lambda is equal to 2 plus 7 mu minus 1 minus 9 mu, then -3 plus 6 mu. Then after that, I decided to find the x, y, and z components. So for the x component, to sum it up, the equation I got was 7 mu minus 10 lambda is equal to -1.
Come again, it was 7 mu?
7 mu minus 10 lambda is equal to -1. And then y was 9 mu plus 4 lambda is equal to 3.
Is equal to 3?
Yes. For the y component.
Okay.
And then the z component, I got 6 mu plus 6 lambda is equal to 2. Now the problem comes in. Okay, I don't know if
6
we
mu
can.
plus 6 lambda
Is equal to 2.
is equal to. Can you first repeat for me for the y? For the y,
For the
there's
y.
something. You said 2
I got,
minus
sorry,
4.
it's negative mu, sorry.
Which
Negative
one?
9 mu plus 4 lambda is equal to 3.
I go back, it is?
Negative 9 mu plus 4 lambda is equal to 3.
Okay.
Yeah, not 9. Yeah. So, okay, I don't know if it's correct, but when I calculated, I was using equation 1, that's the x component, and equation 3, that's the z component. I was getting my mu as 7 out of 51, and then my lambda as 10 out of 51.
Mu was?
7 out of 51. And then my lambda was 10 out of 51.
Okay. Okay, now let people in the chat also tell us what they are getting, in case that is okay. Members, do you get the same, those who have used this equation? And then the third one. Let me, 6. Do you get the same? If yes, I think Martina, it can be okay. Let me also look at it a bit. Martina, it is okay. Yeah, it is okay. It's okay. Remember, when someone who uses the first and the second, and you cannot have the same values for mu, those values for mu are different. Okay, people are saying they're the same. Not yet there. Same things like Martina. Okay, 1 and 2. Then what about people of 1 and 2? 1 and 2. For you, what are you getting? 1 and 2. Debla, for you, what are you getting? Remember, they can't be the same. Remember, they can't be the same. So, some people are not yet there. They have not yet reached there. Okay. Those who are using 1 and 2, I know your answer is going to be negative 13 out of 31, and our lambda is going to be negative 6 out of 31. Okay. So go on and find out whether they lie along the same point. So let's go on and find out. For mu, is it 13 out of 31 or negative? Deborah, can you confirm? Is it lambda negative 6 out of 31? I agree. What about mu? Is it negative, positive? So after getting mu and lambda, go on and substitute and check out whether the points are the same. Whether the points are the same. Okay, let me hope, Shiza Abe, we are on the same page. Abe, hope we are on the same page. Elvis? Elvis, I don't know. Okay. Abe, are we on the same page? Kakande, are we also on the same page? What about Anthony and Cheyenne? Alcantel, Brave Blessing, Chris, hope we're on the same page. Diana and Desire, Frank, Harriet. Okay. Members, are we good to continue? So from the chat I'm seeing, Melissa is saying that the lines are skewed, the points are not the same. Okay. Diana, for 1 and 3 mu is a third. Diana, can we first check out Diana? Diana?
Yes, teacher.
Are you getting 1 and 3? Like when you try to solve?
For me, this is how I had stated my equations.
How had you stated?
For x, it was 10 lambda minus 7 mu is equal to 1. Then for y, it was negative 4 plus 9 mu is equal to negative 3. For my z, it was negative lambda minus 6 mu is equal to negative 4.
So which ones did you solve now? Which equations did you solve?
1 and 3.
What were they?
10 lambda minus 7 mu is equal to 1. Then my equation 3, negative 6 lambda minus mu is equal to negative 4.
Minus mu or 6 mu?
Sorry, minus 6 mu is equal to negative 4.
Negative. How did you get negative 4?
Sorry, negative 2.
No, first check in your book. Is it negative 2 or negative 4?
Negative 2.
From the book, Then how did you solve from here?
And then a bar.
A bar.
Negative 6, 10. Then it was negative 60. 42 mu negative 6 is equal to negative 6. Then negative 60 minus negative 60 mu, sorry, is equal to negative 20. And then the lambda is eliminated, then remain with 102 mu.
102 mu.
Then is equal to 14.
Is equal to
14.
Mm-hmm.
Then when I divide, I get 7 out of 51.
7 out of 51.
Then my lambda minus 7 then my lambda is 10 out of 51.
Okay, which is correct. Is it what you had?
No, I had made a mistake somewhere.
Oh, okay. Which mistake was it?
In my equation 3, instead of negative 2, I put negative 4.
Oh, okay. Okay. Very good, very good, very good. Okay, for 2, someone who uses 23, yes. Even those who use 23, I think your answers will always be different. Okay, Dr. Peace, a question? Yes, Dr. Peace, thank you.
No, teacher, I was just saying, actually, I also used 1 and 3, and I got the same values with the previous speaker. I also
Okay.
got that.
Then when you substituted, what did you get?
I've not yet substituted, sir.
Okay. Okay. Yes, Ruth? I saw Ruth's hand. Yes, Ruth?
So I don't know if I skipped the explanation for it, but I'm seeing in the chat people are saying they're concluding and they're saying that they are skew lines, which I see, but then that they don't intersect. So I was asking, maybe I was not on when you said it, but I was asking how I'm able to know that they don't intersect.
Oh, now the moment you substitute for your mu and lambda in the first equation and the second equation, and you get different points, then it means that they don't intersect.
Oh, yes. Thank you.
Okay. Daisy? Yes, Daisy?
Actually, sir, at the point of checking, you're saying the points are not similar, but what I'm seeing, my first points, I'm getting 2.960.8. Then the second one, for line 1, I'm getting 1.2157. Then the second one, I'm getting negative 2.2353. Then the third one, I'm getting negative 2.1765. These ones are similar. So are these lines intersecting or parallel?
There. Come again. Let me first clean the board. Let me first clean. Which values did you use to substitute for your mu and lambda?
I used the first and third one.
So you got?
I got 7 out. Yes.
And?
7 and 10 out of 51.
And when you substituted in the first line of L,
Yes.
what did you get for your point?
I get 2.9608.
2.96, Then here?
I get 1.21.
Then the last one?
Negative 2.17.
Then for this line M?
I get 2.96.
2.9?
6.
6, eh?
No, yeah. No, the second coordinates I'm getting negative 2.23.
Negative 2.23,
23, yes. Then the last one I'm getting negative 2.17.
2.17.
Yes.
Are they the same?
Okay, for the first one I'm seeing they are similar, and the last one they are similar, except the one in the middle. So I'm wondering.
Now, yes, there is, as long as they are not the same. For even if just one component, those lines do not intersect.
Oh. Okay, thank you.
Yeah. Okay. So for them to be, you must have the same coordinates. The same coordinates.
Oh.
Eh.
Thank you.
Okay. Okay. So, okay. 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 And that's why always I would encourage that for you to get a clear picture, you can even write them in fraction. Like Mattia is telling us negative 29 out of 31. Yes, you'll find that as long as one point doesn't, then it means that they don't intersect. Even if just one component does Z and the rest are the same, then they do not. Yes, Odinga, as members in the chat, you tell me whether we can continue. Odinga? Okay, I'll fail to get Odinga's son. Okay, so members, why don't we have some exercise for this part? Okay. I have the first item there. That is your first item. Hope members have taken a screenshot. Members have taken a screenshot. Yes, Deborah? Yes.
I'm requesting you to first rewind back the first exercise question because I did not take a screenshot of it, please.
Oh, I'm going to go back. I'm going to go back, Deborah. Okay. Then I want to give you another one. Another one is here. So this one I've given you the answers you are supposed to get. These are degrees. Here you get that as your answer. But one thing I want you to do not forget that when you are finding the angle between the two parts, always we dot the directions. Don't forget that. Hope people have taken a screenshot. I don't know whether I have another one. Yes, good. I have another one there. You also go on and take a screenshot. Yeah, those three are enough. Those three are enough. So allow me now to go back. Someone wanted to take a screenshot here. So Deborah, you can take a screenshot for this. Okay. Then that you have this?
Yes, teacher.
Okay. Okay. So members, I think we shall end here for now, for today. I think we have gone past our time. But yes, Odinga's son.
Good morning.
Morning.
Yeah, well, it's not Odinga. It has to be Political. Well, the question I wanted to ask is, hello.
Yes, go on.
Yeah, I wanted to ask. I'm sorry to drag you back, but someone had asked if it was okay to use BA, and you said it was right. So I wanted to ask, does using BA affect the downer part that I have to use DC instead of CD. Because up, if I'm using BA, do I have to change and use DC instead of CD?
No, it does not matter. It doesn't matter. It doesn't matter.
So it means
Though,
that yes,
the only thing that I would encourage is that always to be consistent. To be consistent, because when you read through the thing that the cable is passing through points A and B. Now here, the answer you get will be similar, but for consistency and the flow, like when you read through, is
yes,
like this point, this line passes through A first and then it goes through B. So now the best would have
yes.
been you starting from A and then you go towards B, because like they are putting a cable. So it is passing through A and B. Even now when you look at just the flow, it would have been better that way. That it is
All right,
passing through the C and then D. Yes. So that one would have been better. You start from C and then you go towards D. But mathematically, when someone says B and A, it's like it is moving from B towards A.
all right. Thank you, sir.
Okay. Okay. Yes, Manuela.
Good morning, sir.
Morning.
I was asking if we are really going to end the lessons tomorrow.
Oh, no, we shall not. We shall not.
Oh.
But I will communicate. We are going to continue because I don't know, when are your schools starting? Are they going against the government thing? Are there people who are going back next week? Maybe people can let us know.
We are going on 10th.
On 10th, 11, 8. Okay. So we shall continue next week. We shall continue next week. Okay. Okay. I think many of you are still home. So we shall continue next week. Okay. Okay. We shall have lessons in the afternoon since the internet is on. So we shall have those lessons in the afternoon. Because I know today there are elections. So those who are going to go for voting, please go vote and then come back for the afternoon lessons. They will happen. Then tomorrow we shall have a lesson. However, tomorrow I am traveling somewhere. So we shall start at exactly 5. I'm hoping the internet will be good. And then we shall end at half past 6, such that I can travel fast. Okay. Have a good day. Yes.